In this example, an object is placed 50 centimeters in front of a converging lens, and the lens has a focal length of 20 centimeters. So the object is 50 centimeters in front of the lens, and the focal length is 20 centimeters. The focal length is actually, the focal point is on both sides. We could draw it like that if we wanted to. So F represents our focal length, P represents our object distance, and we can use the thin lens formula that says that 1 over the object distance plus 1 over the image distance is equal to 1 over the focal length. So our object distance is 50 centimeters. Our image distance is what we're trying to find, and our focal length is 20 centimeters. So if I wanted to solve for the unknown q, I need to arrange it so that algebraically it's on one side of the equation and everything else is on the other. So I can subtract 1 over 50 from both sides of the equation, and I get 1 over q is equal to 1 over 20 minus 1 over 50. Now if I put into my calculator 1 divided by 20, I get 0.05. And if I put into my calculator 1 over 50, I get, 0.02. And so what that tells me is that 1 over the image distance is equal to 0.05 minus 0.03, which is 0.03. But we're not done yet, because that's not telling us what the image distance actually is. That's 1 over the image distance. So we can cross multiply, or we could multiply both sides at this point by q. That would cancel the q off on the left side, and I have 1 equals 0.03 times q. And then to solve for the unknown, I can divide both sides by 0.03. And when I divide that out, I get that the image distance is 33.3 centimeters. So I've solved for the first part, which tells me that the image is located 33.3 centimeters in back of the lens. Or another way to say that is it's on the opposite side of the lens. So the fact that this turns out to be a positive number tells me that it's on the opposite side of the lens as the object is. Now the other part to this question was to determine the magnification. And by definition, the magnification, there's two ways to write it, but one way is to write it as the negative of the image distance over the object distance. So this would be minus 33.3 centimeters over 50 centimeters. And when I put that into my calculator, I get negative 0.67. So my magnification is negative 0.67. So what does this tell me? The negative tells me that the image is inverted. And the fact that 0.67, the magnitude of the magnification, is less than 1 tells me that it is smaller than the object. So the image is smaller than the object, it's inverted. So the magnification actually tells us a lot about the image that's formed. It tells us whether it's going to be upright or inverted, and it also tells us its size compared to the original object.